Hello again, my name is Dr. Bill Johnson. I'd like to welcome you to another edition of Exploring Our Schools. This is a really exciting day for me because we're going to have an opportunity to share with you some of the really incredible things that are happening in our elementary schools. I guess what we would just call it is just enrichment. And we've built a program in our libraries. We call it Stellar, and we have Stellar teachers in each of our elementary buildings, where we provide our children the opportunities just not to read, but to engage in all kinds of activities. And we're going to talk a little bit about some of those activities today. So I have with me some very special guests, one of our Stellar teachers, Veri Pedersen, teacher at Wilson School, and we have two fifth grade Wilson students with us today. Tommy Quilty, thank you very much for joining us. And Sophia Mena, thank you very much for joining us. I'm going to start with the teacher and talk a little bit about Stellar and then what we're going to be talking about today and how it kind of fits into the Stellar program.
Stellar is ever-changing, always exciting. Is it fair to say? We're reaching for the stars in our Stellar class, and we're grabbing them and pulling them down for all of us to use, right? This year we're doing something, again, a little bit different. We've been working along the line of using this STEAM initiative, which refers to science and technology, engineering, arts, and mathematics. And I have to tell you, Dr. Johnson, I was a programmer in a prior life. As a programmer, I used to design many, many systems to look at these kids who are digital natives, who are experiencing in grades K through 5, actually, coding, and they're picking it up in an amazing manner is just fantastic.
Yeah, but the language today, I mean, I grew up with programming as well,
Right.
and we understood what that meant, and it was writing things for computers when the computers were not as sophisticated. So really what I'd like to hear from one of you to tell me a little bit about the no language is coding. Where does that come from? I mean, it's connected to something else, and we'll get to this thing sitting out here. It's not a very handsome representation of what a robot looks like, but it does its job. But let's start with coding. Who would like to kind of jump in and tell us a little bit about coding? What does that mean?
So we have a couple sites that we go on to in Stellar, and one of them is called code.org, and there are levels that teach you how to use the different parts of it. So there can be move forward, there's move right, move left. You can do things over and over again. And it's really nice because it has sort of like video games that all the kids would play these days. So it has like Plants vs. Zombies and Angry Birds. I haven't gotten very far though.
So you're communicating with the computer,
Yeah.
right? So you're basically giving the computer instructions on things that it wants something else to do, right?
Yes.
So have you done it?
Yeah, so we do it in Stellar, and usually Ms. Patterson, she puts it up on the smartboard, and we do it usually individually, and we go to one of the numbers, but yeah.
You do it, okay.
Yeah.
So tell me a little bit about what coding is connected to. I mean, it's a means to an end. I mean, it's just not something we want to learn for the purpose of learning it. It really helps us do something else usually.
The beauty of the code.org site is that it started teaching the kids about the connection, and we've talked about this earlier many times, between the use of programming code in our society. And because these kids are digital natives, they're very familiar with technology in many, many, many iterations. We use it on in our cars, on our phones, even at the banks as part of, when we go to automatic teller machines. Programming is all around us. I mean, there are smart stoves, for that matter. I mean, it's everywhere, where we don't even realize it. What the children have learned is that we've taken from the code.org site, we've moved to the next level, which was the introduction of robotics. As we progressed with our understanding of code, our students were able to actually start coding the robots and creating many, many different things.
See, I always thought of a robot as looking just like you. I mean, somehow along or you. I mean, think about it. That's what I always, when we were kids growing up and we wanted to produce a robot, the robot. Now, that is a robot. Doesn't look like you at all. Huh? So what does it do and what is it?
It's called an S2 robot, and you can put a Sharpie in the hole on the top of it, and it will,
May I?
yeah,
Thank you. In the hole?
in the hole,
So what do you put in the hole?
a Sharpie,
A pen.
a pen or a Sharpie, whatever fits,
Okay.
and you plug a cord into the computer, which downloads your code onto the robot, and then when you're ready, you can unplug it, get it ready, put it on. If you want, you can put it on a piece of paper, unless you want to write it on the table. You can create designs with what you
So
have
this thing doesn't
coded.
think for itself.
No.
So getting back to coding, this is what you guys do in Stella. I mean, you sit down and figure out what it is that you'd like it to do.
Yeah.
Then you have got to figure out how to communicate with the computer. So you use code to do this?
Yes.
And then what?
And then we will put it on a piece of paper, and it will make the design that we want.
You did this?
Yeah.
How?
We used a template, and so we took
But who wrote this? I mean, who drew that?
the robot did.
The robot.
Because the pen inside of the hole, you put it down, and this one would just make triangles and go around in a circle with the triangles.
Yeah. So if you could hold this up just for a sec. That is a very interesting design. Now, you taught this how to do that.
Yes.
And what you did was to repeat a design. Now, when I look at that, what does it look like? I mean, it looks like something very circular, but in fact, what is it?
It's a bunch of triangles.
Oh, a bunch of triangles, right. So, did you do something similar to that?
Yeah, we did. There's like a bunch of different designs you could choose from. We did a flower in our class,
Uh-huh.
and it was basically just a lot of circles instead of triangles, and it would create the flower.
And how did that work? That it just kept going around from one place to the next?
Well, they would set it to make one circle, but then you can also make it repeat a bunch of times.
What did we call that? Do you remember? Begins with an L. Loop.
Oh, loops.
Yeah. Iterative loops,
Yeah.
right?
And it'll just keep repeating that, and you can set it to how many times you want it to repeat it.
See, but the important thing is that you've got to think this through. You've decided in advance what you want it to do. You've got to teach the computer what to do. Then the computer, right, communicates with this thing, right? And I call it a thing
Yeah, but
because
it is.
I'm having a hard time. I mean, I don't know where the eyes and the nose are, but I guess somebody decided that in the front could be a simulation of that, but nevertheless,
It's,
and it gets around on its wheels, right?
Yeah.
Tommy, tell Dr. Johnson about the races we've had.
Down the hallway, we'd first make it so it would move forward once, and then we'd loop it, and we would do it however many times you'd think it would take it to get it down the hallway to our classroom. So we'd have to predict how many times we wanted to loop around, and whoever got the closest would win.
Now, when you say loop around,
How many times it would go forward. We
Yeah.
were making it go forward X number of times. The children had to actually calculate the amount of space that they were using every time they were going through a particular command, how they were going to go forward or turn or do whatever they were doing. But the goal ultimately was to get all the way down the hall at Wilson School, and they had to loop
so you got to know what the
through.
destination is.
Absolutely.
So you figure it out.
There
You
were
go down to your
calculations
class.
involved. The
Really?
the mathematics component.
A little like the GPS system you have
Exactly.
to create, right?
Exactly.
So when GPS is done, you've got to figure out how to get it from this point to that point,
Precisely.
and faster than anybody else. Huh? Did you win?
No, ours, we didn't come in first.
Oh, no.
Ours
Oh,
was too short.
But
All right.
were we driving everybody else crazy in the hallway?
Oh, yeah. Other teachers came out and,
Everybody was looking.
yeah.
I don't blame them. It's very
It's
interesting.
It's very exciting, and our stellar classes across the district are very, very exciting. I think they're very stimulating for our children, and I do think at the elementary level that we really prepare our kids for movement on to the middle school and beyond. They are our future.
You know what, let me ask you another kind of an adult question now.
Sure.
But, I mean, we've kind of walked ourselves through the routine of what they're involved in. Why? What's the purpose of it? I mean, why teach this?
Well, ultimately, the goal is to prepare them to be our nation's leaders. And as such, they are they're stepping up to the plate and moving forward at an incredible rate. We want them to be success stories in our society, and we want them to have a keen understanding of how things work. And that's really part of it. We talk about current events. We talked about the Consumer Electronics Show and drones, right? Did we talk about drones? Oh, my goodness. We talk about the Roomba, that is the vacuum cleaner, that is a robotic vacuum cleaner in your home. And we're making these connections, real-life connections, to what we're studying, which is vital in our stellar classes.
Yeah. You know, I've been sitting here looking at myself sitting there.
Oh.
With the blue shirt and the blue little sign over there.
Tom,
Now-
you want to talk about it?
This was made by a 3D printer,
Uh-huh.
and there's software you can get that you can basically type in a word or put in like a design or something. So this is made on a 3D printer, and what it does is there's this plastic material called filament that goes into this extruder, which heats it up and makes it nice and like wiggly, like kind of like
Melted.
pasta.
Melted a little.
Yeah.
Like
And-
pasta.
Like pasta. Yeah, you're right.
I know, I've seen it.
and then it layers it until it gets to the top of it, and then it's done.
How long does that take?
This one took about an hour.
Yeah.
Really?
It
Oh, it's
really
pretty quick.
depends upon the size of
Yeah.
what you want to create.
Yeah, tell me others. I mean, I really appreciate that's very kind of you to do that, but I suspect that there are other creations that you've put together, right?
Yeah. Well, there's websites you can go on, and they have a bunch of different like models you can make of stuff, like really anything.
But interesting to note again, when we're talking about making these images, these models, these 3D models, we're still using coding. The people who have created these models are using different applications to go ahead and create that. So that's the end result. But when we go back to our code.org
Yeah.
beginnings, that's where we
Yeah,
start.
but you've got to figure it out. Now, did you know in advance, before, you know, this drawing that we have here, did you know what it was going to look like before you designed it?
No,
You didn't.
no.
So what did you do when you gave him the order? Gave him
Well,
this thing, the order.
Yeah. We put it on a piece of paper and it started to go in triangles. So I thought it would make just a bunch of triangles, but usually it goes just not in a circle. It maybe will make a bigger thing, but it was really weird to me how it was making something as small and it was just turning and
Going around
triangles.
in a circle. Yeah.
And then, correct me if I'm wrong, was it your class where we started changing the code in terms of the degrees and
Yeah.
the loops themselves?
We did change it, but I don't know. Did we get time to
I don't know if
actually
we
try
did.
them?
We might have. I don't know if we did, but we were busy working on seeing how if we modified the code, if we changed the code, how the image itself would be modified, would be adjusted.
So I'm somewhat fascinated in that, how do you figure this out? I mean, you know, it's not like reading a book. So somewhere in that brain of both of you,
I don't really know, but I put in a couple commands, and then you see what it looks like. And if you want to change something to make it go a different way, then you go back on the computer. You can put it in a different way, and then try again.
okay, and you do the same thing?
Yeah, it's like experimenting with it.
It is experimenting with it, as a matter of fact, that's right. But you need to have some real skill to do that to
Yeah.
begin with, right? Which is amazing. So the skill is in the coding? I mean, you've got to be able to give the computer the commands that it needs.
Yeah. But for like the software, it's not like that complicated. It's just like move forward, turn right, turn left. Like it's not too complicating.
For you.
Yeah.
Because you've had some experience.
Yeah.
The other thing I have to say is, guys, when you're doing this coding stuff, are you concerned that you're going to make a mistake?
No.
No. It's a very different thing from, say, our world.
Right.
These kids are willing to reach out again and grasp those stars and try their best. And they're not afraid of making a mistake. And I think that's why they get so much out of it.
Now, do you work as teams?
Yeah, with our tables.
We only have 8 robots, so we do work in teams.
Okay, so what do you do? Let's just take, you go down the hall and you say, how do you measure that? What do you use to measure it?
Well, we haven't really measured it exactly yet. We've just predicted.
Okay, so you predict about how far it is, right?
Mm-hmm.
Now, how do you do that? You just stand out in the hall and you say, 40
Yeah.
feet, 50 feet?
Yeah, sort of.
Okay, and then what? So it's problem solving, I guess, right?
Yeah, and then you go try it out, and if it doesn't work, you know to modify it like the next time you do it.
And who does all of this trying? You do it with your team?
Yeah, with our tables.
Yeah? So you help each other?
Yep. Well, only the people like in our group, not like the other group.
Not the other group, because, right, you're competing with them, I guess. All right? So, tell me a little bit about, in your own mind, what do you think is the future of robotics? What do you think it's eventually going to do for you?
I think it's probably gonna be it's gonna do almost everything for you,
Uh-huh.
like wash the dishes, like
Oh, wouldn't that be nice?
yeah.
Yeah.
Take care of all our
I think it does
chores.
already, though, but you have to clean them a little bit and put them in a
Yeah.
machine.
Right.
There's still something we have to do, right?
Mhm.
Maybe it could clear the table.
Yeah.
You still have to take the dish from the table and put it someplace, right? All right, so what else might you think it could do?
We'll make robots to drive us places. Or
What did we study
we studied.
when you talk about driving places?
We looked at the Google car, I think it's called. There are already cars that have already sort of can drive people anywhere without them even having to touch the steering wheel.
The Google car actually doesn't have a steering wheel.
Yeah.
Has no pedals and no steering wheel, so it's a little strange environment. There are other cars that are produced that have actually steering wheels, but they drive by themselves. So, at any rate, I wanted to thank you both for coming on and sharing with us a little bit about what goes on in Stella and giving us an opportunity a little bit. Now, do I get an opportunity to take the sign with me?
Yep.
All right? So you know where that's going to go, right on the middle of my desk. I think it's wonderful, and I thank you very much. So,
We thank you
Very-
very much.
just, look, it's a great opportunity for us to let people know that school is so different than it was when we went and sat in a classroom all day long.
It's exciting.
Well, other things, I mean, I would hope that reading and math is exciting too, but this
Absolutely.
adds a whole
No,
dimension
no, school as
to
a
all
whole.
of that.
School as a whole is
Yeah,
exciting.
which allows so many more things to be thought through. So, thank you very much.
You're welcome.
Thank you.
Thank you.
Thank you. Thank you for joining us today, and we look forward to seeing you next time. Isn't it wonderful what children can teach us about the world to come?
It's true.
So, thanks for joining us again, and hope to see you next time. Bye now.